Hey everybody, I wanted to take a look at this IB problem packet that I gave you. These are paper 2 and paper 3 problems from various years, and your exam is going to be covering, I would say, you're going to have, just so you know, the structure of your exam, and I'm going to give you a mock exam when I see you in class either tomorrow or Tuesday, and I'll put video solutions and PDF solutions on Haiku for you. But just so you know, you're going to expect 20 paper 1 type questions and 4 to 5 paper 2 and 3 type questions. Just be aware of that fact and adjust accordingly. You'll have 80 minutes for the exam, which will be exactly the time that you would expect for. It's actually a little bit more time than IB would give you, given the structure of the exam. The other thing, you are allowed a 3x5 index card. I'll be reviewing all this with you. So again, 20 paper 1 problems, 4 to 5 paper 2 and 3 problems, and a 3x5 index card with anything you want written on it. That will be allowed. Now, what I want to do today is go through these problems that I gave you last week, and what I'm going to be doing is, before I solve the problem, I want to go through all these problems the way an IB teacher would or an expert IB student would, the kind of student that would score a 6 or a 7, and talk about what I look at in problems before I even try to solve them. Okay, so for example, I'm looking at this question B1, and right away into my head pops this idea. Aha, this one is moving. Now I'm going to scan. Is the car moving? So I scan. Aha, the car is stationary. And right away, when I see two things like this, a car and a van, two objects, one moving, one's not, the first thought that pops into my head, so I'm going to call this point 0. Point number 1 that pops into my head is this has got to be a collision problem. And to me, that's going to mean momentum conservation. And so what I'm going to want to do is just kind of scan and see if I can find the word collision in there. So I'm just going to skim it. Oh, there it is. So definitely we're going to need momentum conservation. Now the problem is there's a formula here that we use, which is M1 V1. But I don't want to use 1. I want to actually label the objects in the problem. Do they tell us what they are? Let's scan and see. So we have the word van and the word car here. So this is the van. This is the car, and it looks like they give us masses, so let's speak to this point. So the mass of the van is 1,200 kilograms. The other thing, let's be clear, the weight of the van is going to be M times G, so that's going to give us 12,000 newtons. Please be able to go back and forth between these things fluently. The mass of the car is 800 kilograms, and the weight of the car is 8,000 newtons. I want both of those labeled. I don't know if I need both. I write them down anyway. So this is point number 2 right here. I haven't finished up point number 1. I'm jumping all over the place, and that's a bit deliberate. This is actually how I solve problems. Now it says the frictional, I'm kind of looking at these bullet points here. These seem like important points. Let me skip to here and see, but before I do that, this collision problem, momentum conservation, let me finish up that point, and then I'll go through these bullet points here. So I'm going to write M1 V1, sorry, not M car V car. You know what, though? I want to use IB notation. So 15th times the charm here. Sorry about this. We got the mass of the car times its initial velocity, sign matters, plus mass of the van times the initial velocity of the van is mass car V car plus mass van V of the van. This is the statement of momentum conservation. I want to make a very important point here. I'm going to write this in purple. This formula is not in the data booklet. So you'll need to actually have that figured out. The one they give you in the data booklet is that momentum is m times v, not necessarily helpful. Okay. So we're told the car's frictional force is 30% of its weight. I'm just working up on these bullet points because I can. So I know the car's weight. I calculated that. Remember, that's m times g. Okay. This is given in the data booklet. Now, it's 30% of the car's weight, so let's just work that calculation out, okay? So when we work that out, that's going to be 0.3 times the weight, 8,000. So that's going to give me 2,400 newtons of friction force. And I'm going to label that with an F, subscript F, just the way the IB does it. The handbrake only acts on the rear wheels. I'm not sure if that's useful or not, but I take note of it. Now, it says the skid marks on the road are 15 meters long, made by the car's rear tires after the collision. Okay, so I'm going to tell you right now, I have some kind of a distance here. And I'm just going to tell you right now, this is experience. This is a trick that I use, and I'm passing it on to you. I'm going to tell you right now, there are two formulas that I think of when I think of things skidding to stop. The first one, it's a kinematics formula, meaning motion, acceleration, velocity, position, speed, where I don't talk about forces. That formula is in the data booklet. It looks like this. V squared equals u squared plus 2 times the acceleration times the displacement we go through. So just to be clear, this is in the booklet. Now, it turns out there's another formula. I don't know which one of these is useful. I'm going to write down both formulas that I've used in my experience as a physics teacher. There is the work formula. Work is the change in kinetic energy. That is not in the data booklet. And I'm going to expand it out. Work is force times S, and delta KE is 1/2 mv squared minus 1/2 mu squared. So I'll tell you right now, this is not in the booklet. I'll tell you what is in the booklet, though. They tell you that work is F times delta X, and they tell you that kinetic energy is 1/2 mv squared. Those are in the data booklet. But that's about all you're going to get, okay? So this seems to be the information that I have right now. And so this is all the stuff that I write down before I even begin the problem. Let me be clear. I don't even know what they want from me. I'm just writing stuff down that I've used in, oh boy, at this stage in my life, literally hundreds, if not thousands of problems. Okay? So this is how I actually set up the question. And in the next video, I'm going to go ahead and actually do the IB math to give you solutions to part A and part B.